Yeah, good evening all. Everyone can hear me? Online students? Online students, is my voice is loud and clear? Done. Okay, so let's start the session. And in the last class, we have seen the what is the meaning of dimension reduction. In the dimension reduction means reducing the number of input features, where the number of input features, okay, where we can reduce the number of input features uh, using either feature selection techniques or PCA. So by using the PCA also, we are going to reduce the number of input features. And I have told you how the PCA works. So let us see one example related to that. I mean, one project based on that. Now, in this particular project, whatever we are going to do with PCA and we'll see without PCA, both of them will understand the difference. What is the difference between the PCA versus with so let's start this. Okay. So first, I'm going to import the pandas as PD, and I'm going to load the data set called as a wine data set. Now, what is this data set means? This data set belongs to whether the wine, the quality of the wine, whether we are having in the wine quality, three categories are there. If you observe this one, it is having total three categories. Okay. Quality one, quality two, quality three. So it is having total three categories. So the output variable is multi-class classification. So the output variable consists of multiple labels. Okay, so multi-class. The output variable is multi-class. Now coming to the input variable. Now coming to the input variable. Now input variables, we are having different attributes. These are the various physical attributes. And with respect to based on the alcohol percentage, based on the malic acid, ash, and magnesium, phenols. And based on all these things and color intensity, based on all these values, we have to predict whether the quality of the wine is 1 or quality of the wine is 2 or the quality of the wine is 3. So already they only have done the encoding for the output variable. Generally for the output variable, we have to get the good quality, average quality or bad quality. Good, average, bad. Here directly in the given data set itself, they have done the encoding. Okay, they have already done the encoding. Directly, sir, how I can know which one is good and which one is bad or which one is this one? Means that you can see charges. Okay, that you can see in terms of by using the data set description. So for any data set, they'll give the description of the data. If you see this data set I have taken from the UCI machine learning repository. So already I have told you from where you can download the multiple data sets, out of which one of them is UCI machine learning repository. This is one of them. And we are having second one is Kaggle. Generally, we will download the data sets from these two web sources. So this, whether it is a UCI machine learning repository or whether it is a Kaggle, okay, out of these two, in the each of the website, we are having with more than 50,000 plus data sets. Whether it is a UCI machine learning repository or whether it is a Kaggle, more than 50,000 data sets are available. So I'm just downloading one of the data set from UCI machine learning repository. So here, if you observe this wine data set, I have downloaded the wine data set. So like this, you are having with respect to multiple data sets. Okay. So in this, I'm having the wine data set where this wine data set has the different physical attributes. So these are the different attributes and it is having with respect to quality. Okay. The quality as the output. Now, if you see here, the physical attributes or this one, you are going to understand the data and what is this attributes means and what are the different parameters and what are the different characters are there. everything you are going to check. Now, here, this data set, whatever the data set I'm working today, this data set consists of 3 categories in the output variable. Okay. Now, how many input variables are there, miss? The input variables are 13 input variables are there. So now total 14 columns are there here. Total 14 columns. Out of 14 columns, 13 of them are input and 1 is output, where the index number starts from 0 to 13, and the quality, the last one is the output variable. The last one is the output variable, which is the quality, and remaining I'm having 13 input variables. Now, generally, forget about PCA. There is no PCA. Generally, I'm having a data set like this. What we are going to do generally for the given business problem? First, I have to understand the business problem. What is the business problem is? I have to create a predictive model which can predict the quality of the wine with the maximum accuracy. It has to predict the quality of the wine. Either it belongs to category 1 or category 2 or category 3. With maximum accuracy, you have to create a predictive model based on the given characteristics. That is the business problem. We have to do with the maximum accuracy. Okay. Now, first business problem is clear. Next one is data understanding. Data understanding is these are the different characters of the any wine. So it is going to have some kind of proline chemical and color intensity, and it is going to have some acid, ash, and alcohol percent and magnesium percent. Like this, it is going to have any particular wine mix. It will have these are the characters, right? Now, using these characters, I have to predict. Generally, what we'll do first, data pre-processing. We are going to do data pre-processing means first we'll check the anything we are having in terms of missing values. That is df dot is null dot sum. First, we'll check the missing values. Okay, is there any missing values are there? If there are no missing values, so in my data set, there are no missing values. Compulsory is missing values, and second compulsory is encoding. So here, if I observe my data set, everything is float or int. There is no object only. So since there is no object, I no need to do the encoding. Directly, I can proceed with the normal one. Now here, if you observe this one, this entire columns, whatever the data I'm having, total 14 columns, out of which I'm dropping the last column. The last column, that is quality. After dropping the quality, remaining whatever the 12 columns are, 13 columns are there, that I'm going to consider in the X, and the last column I'm considering in the Y. So you can take in the last column like this also. Directly you can take like this by using the bracket quality. Okay, directly you can take the quality. So this is with respect to df.drop quality, that is output variable. Remaining all of them are input variables, and last output variable is this one. Now X, if you see the X variable, I'm having the X variable of total 178 records with 13 columns. Okay, and Y variable is 178 records with 1 column. 178 records will be there, but column is only one, that is output variable. Now what I'm going to do, I'm going to take the train test split. Train test split with X train, X test, Y train, Y test, and I'm going to take the test size of 0.2. Now total how many records are there? 178 records are there. I'm opening the calculator. Now 178 records are there. For 178 records, I'm going to take 0.8, which is nothing but 142.4. Round figure is 142. So 142 records are used for training purpose, and remaining balance, how many will be there? 36. Balance 36 records I am using for the testing purpose. Total 178. Right? Now if I open my X train, I'm opening the X train dot X train, X underscore train. Now if I see the X train, I'm having with 142 records with 13 columns. Now there is no PCA, nothing is there. Generally, I'm just applying the K nearest neighbors and random forest classifier. These two algorithms I'm going to apply. From sklearn.neighbors, import the K nearest neighbors. And in the K nearest neighbors, I'm going to take the default parameters, and I'm going to fit on the X train, Y train, and I'm going to predict on X train, X test, and I'm going to see the train accuracy, test accuracy. And I have got the train accuracy of 78%, test accuracy of 80%. Default model. I'm doing for the default model. I'm not doing any hyperparameter tuning, nothing. So this model KNN has given me the train accuracy of 78%, test accuracy of 80%, right? Now, here, how many input variables I have considered? X, how many input variables? 13 variables. 13 input variables I have considered. 13 input variables I have got for KNN this value. Let us try for the random forest classifier. Same way, let us try for random forest classifier. For random forest classifier, I'm having with respect to train accuracy of 100, test accuracy of 97.2. By considering 13 input variables, I have got this one. Okay, keep this one aside. Default only. I have not done any kind of hyperparameter tuning, nothing. Here I'm not comparing between the models. I want to compare between the PCA versus non-PCA. That is my comparison. If that is my requirement, means remaining all other parameters should be constant. I'm not focusing on the data, or I'm not focusing on the modeling, or I'm not focusing on the important hyperparameter. That I'm not focusing on that. With the PCA, what happens? Without PCA, what happens? Only I want to see. So just I'm applying the basic model and I'm going to observe the difference. Now this is a KNN algorithm which was given the answer as like this with the random forest like this by considering 13 input variables. Now let us try the same thing by applying the PCA and we'll see the difference. If I take the PCA, what happens? Now for PCA, what is the first step I have to do? Scaling. That is standardization you have to do. So for that, from sklearn.preprocessing, I'm going to import the standard scaler and I'm going to fit underscore transform on xtrain and only transform on the xtest. As we know that scaling we are doing, whenever we do the scaling should be applied only after the train test split. Only after the train test split. So after the train test split, we have to take separately. For train data, we have to apply training. And for testing, we have to do separately. Otherwise, it is called as data leakage problem. This already I have told you. Now, from sklearn.decomposition, I'm going to import the PCA. Now, PCA, n components is equal to 0.95. What is meant by 0.95? Means which contributes a total of 95% information. I want to collect that one which contributes with a total of 95% information. So it is going to select the data. And now if I'm applying a PCA on the xtrain, PCA on the xtest separately, so that the number of input variables will be reduced. Now if I observe this PCA, my PCA is having 142,10. Earlier, what is the xtrain? What is the xtrain shape? Here itself you are having. This is your xtrain. Now xtrain is 142, 13 input variables. Now xtrain underscore PCA. Whatever you are having, the xtrain underscore PCA is 142, 10 input variables. Okay. The xtrain before PCA, the xtrain data after PCA. Okay. So xtrain with PCA, if you apply, you are just getting off 10 variables. So 3 variables, it is transforming that 3 information, other 3 variables information into this one. And we are ignoring the 3 variables, right? And here, if you observe this one, explained variance ratio. Now, what is meant by explained variance ratio? Means the weightage of each column. The first column weightage is 36%. Second column weightage is 19%. Third one is 10%. Fourth one is 7%. Like this, I'm having with respect to each of them. Yesterday, I have told you, first we have to calculate the eigenvalues. After calculating the eigenvalues, from that, we have to calculate the weightage of the each eigenvalue. The same way. Now, if you observe here, just clearly observe this one. In the KNN neighbors, K nearest neighbors, what I'm going to fit on xtrain, I'm going to fit. This time, now when I'm fitting on the xtrain, ytrain, how many input variables it is going to consider? 3 of them, it is 13, it is going to consider. 13, it is going to consider. Now, whereas xtrain underscore PCI, I'm taking K nearest neighbors only, same to same. But this time I'm taking extrain underscore PCA, fit on extrain underscore PCA. Now extrain underscore PCA consists of 10 variables. Now earlier for KNN with 13 variables, what is the answer I have got is 78 and 80%. Now let us see this one. What is the answer I'm going to get? 97 and 97%. So by default model only, I have not changed even the better model also. Default model only, suddenly the accuracy has increased. In the default model only, the accuracy has increased. Got the point, guys? So for the given data set only, for the given data set, that too in the KNN only, initially I have got one accuracy, now I'm getting another accuracy. Accuracy has increased. Similarly, let us see for the random forest. Okay, for random forest. But random forest accuracy has not increased. Every time it is not mandated that accuracy should increase. Why I have taken random forest also? Because earlier I have taken only KNN. I have shown the differences only the KNN. But one of the students has asked me, sir, I have applied this PC on the random forest, sir, but random forest has not given me the better result. See, sometimes PCA advantage, sometimes the PCA will increase the accuracy. Sometimes it will increase the accuracy. Sometimes it may not increase the accuracy, but surely it will decrease the number of input variables. This is fixed. Decrease the number of input variables is fixed. So if you observe, though it is a random forest, though I have got the same answer also, but earlier random forest is with respect to 13 input variables. This random forest is just with respect to by considering 10 input variables. Okay. So extrain underscore PCA, that is the reason I have taken separately. Underscore PCM is which is having after PCA the extrain data. Now it is having only 10 input columns. It is not designed on based on 13 input columns. It was designed only based on the 10 input columns. So now you can clearly see the difference that the PCA advantage is it is going to reduce the number of input columns without decreasing the accuracy. It will not affect the accuracy. Without decreasing the accuracy, it will reduce the number of input columns. Is that clear? Sir, how to check whatever the input variables are removed? Exactly. Yesterday also I have told the same question. The answer is with respect to, we can't see which column was removed. We can't see that one because the data was transformed. The data was transformed. It is not the original data. For example, I'm having 1, 2, 3, 4, 5 students are there. Total 5 students are there. I'm removing the 4th student. I'm removing the 4th student. I'm going to remove. But when I'm removing the 4th student, if I remove directly like that, then I can say I'm removing the 4th student. But his knowledge was transferred to the other students. His knowledge was transferred to the other students. Now, other student initially, whatever they are having the knowledge, now knowledge also same. Huh? No, it is different, right? Means now the data was entirely transformed, converted. There is no original data only. So since there is no original data, how I can say that which variable I have removed? Is the point is clear? Got the point? So the original data has transformed. It is not as in the original position. If the original data is as it is in the original format, means I can say that these variables have deleted these variables, and I can say this total of 39% here, whatever you are saying 36.88%, which column is having that value here, which column is not, that is not the one. Okay, because all the data was transformed into another variables. The original data I'm not considering. The original data was converted to the covariance matrix. Covariance matrix. And after converting to covariance matrix, for the covariance matrix, I have calculated everything. If I calculated for the original data, means I can say that for this column, this is the weightage. For this column, this is the weightage. But that is not there here. Okay, is that clear, guys? Yes, CV also you have to check. Absolutely, you have to check the CV also. Just I'm focusing with PCA, without PCA. So till X, whatever the original X is there, 178 into 13 columns. Okay, once again, I'm writing here. X is the given X variable. The given original X variable is 178 into 13 input variables, out of which it has been converted to X train with 142 into 13 variables, and X test was converted with whatever the X test I'm having. The X test is 36 into 13 input variables, 36 records into 13 input variables. First, it has been done like this. Now, by applying the PCA, this 142 into 13 has converted to 10. After applying the PCA, it has converted to 10. After applying the PCA, it was converted to 36 into 10. The number of input variables has been transformed to 10 only. If you don't transform, for example, here, whatever the data is there, if you don't take this fit and transform on X train and fit and transform on X, if you don't consider the transform on X test, then you'll get an error here. When you're asking to predict the model was created with 10 input variables. While giving this prediction also, you have to give 10 input variables. You can't give 13 input variables as the input. So that 13 variables has to be transformed to 10 variables, and then you have to give the input. Then only it will work. Is that clear? Sir, can you explain this n component value once again? N component is nothing but how much percentage of data you want to consider. So as per CRISP-DM methodology, we have to take the minimum 95% of the data. So how much amount of the data you require? For example, they asked you to create a model with by considering only 5 columns, means directly write the number 5 only. Now n components is equal to 5 means it will take only with respect to 5. Directly it will take the 5, top 5. It is not going to change the weightages, but first top 5 records. So top 5 n components it is going to consider. Now if they ask you to create a model with 7 columns, means you can take it by the 7 columns. If you have not given with respect to number of columns, generally none of them is going to say color to only 7 columns, take only 8 columns. They'll not say like this. Consider minimum 95% of the data. 95% of the information should be stored. Remaining 5%, okay, not a problem. But 95% of the data should be stored. Right? So we are going to consider n is equal to 0.95. That meaning is we are considering 95% of the data, which contributes overall 95%. If you add everything, you'll get the minimum 95%. If you don't consider this one, you may get up to 94.8 only. So if you are getting only 94.8% means, so that you have to add the one more. Cumulative. Do you remember the cumulative frequency when I have discussed the cumulative? Do you remember the cumulative? Cumulative probabilities, guys? What is the cumulative probability and what is the difference between a normal probability versus cumulative probability? In the descriptive statistics, I have told you one example. That example is in the probability distribution, coming to the continuous variable, this one, while explaining this particular topic. Okay, here I'm having 5, 6, 4, 3, 2, and these are the corresponding probabilities. So how many students are there between 90 to 100? Means 5 students are there. Between 100 to 110, 6 students. From 110 to 120, 4 students. From 120 to 130, 3 students. From 130 to 140, 2 students. This is called as count or frequency. Heading is frequency. Now the same thing, if I calculate the probability for each interval, what is the probability of each interval? Means 0.25, 0.3, 0.2, 0.15 and 0.10. Right? So how you got this one? probability values, just 0.25, which is nothing but 5 by total, that is 5 by 20, which is 0.25, 6 by 20, 0.3, 4 by 20, 0.2, 3 by 20, 0.15, 2 by 20, 0.1. This is called as probability. Now I want the cumulative probability. Now what is meant by cumulative probability? Next we have discussed cumulative probability. What is meant by cumulative probability? From 90 to 100, what is the probability? Miss 0.25. I want from 90 to 110, from here to here. 90 to 110. Then what is the answer? 0.25 plus 0.3, which is 0.55. From 90 to 120, what is the probability? That is 0.25 plus 0.3 plus 0.7, which is 0.75. Now from here to here, 90 to 130, what is the probability? 0.90. From 90 to 140, what is the probability? 1. This is called as cumulative probability. Now, if I want up to 90% probability, from which values I have to consider? If I want a 90% probability, miss, from 90 to 130, you have to consider. In the sequential order, you have to consider up to, which is combination. First, you are going to take this one. By adding these two, you are getting only 0.55. By adding this one, 0.75. By adding this one, 0.9. So if my requirement is which one, by adding, I will get the 0.85. Miss, what you are going to do? First, you will take this one. You will add this one. You will add this one. You will add this one. Like this, you will check one by one, where you are going to get minimum 0.85. For this, you are not getting 0.85. Not 0.85. For this, only 0.75. If you add these two, you are getting only 0.75. When you add this one, then only you are getting up to minimum 0.85 requirement is satisfied here only. So then what you are going to do? You are going to take from 90 to 130. Right? In the same way, here also same. In the PCA also, it is going to take the same. In the PCA, whatever the PCA is there, in the PCA, just what it is going to do, miss? First, it is going to take this one. Now it is going to combine these two. After it is going to combine these three. After it will combine fourth one. After that, it will combine the fifth one. Each time it will add next one. And you will get with respect to, by adding one by one, you are going to check till what you are going to get the 95% one. And finally, you are going to take that one. Is that clear? So if you want to see all the probabilities, okay, 13. I'm taking all of them. All of them I have considered. Now, just try in your thing. First, you take the first one and add the second one, two of them. What is the probability you are going to get? What is the weightage you are going to get? What is the weightage? By adding first two. Just open the calculator. That is 0.3688 plus 0.1931. Up to 4 decimals I am considering. So I'm getting 0.56. Okay. If my requirement is 0.6 is my requirement, assume. Is this sufficient? Two of them are sufficient? No. Now, if I add third one, in the sequential order, I'm adding the third one. That is 0.1075. Now, for 60%, this is sufficient. So for getting the 60%, how many input variables I have to consider? 3 of them are sufficient. So here I'm writing with 0.6. For 0.6, how many are required? Only 3 are required. It is taking only 3. Why it is taking only 3? Because these 3 cumulative is 0.66 only are getting. Miss, your requirement of 0.6 is satisfied. For 0.7, this is satisfied. 0.7, it is satisfied? No, you have to add still more. Something you have to add. This is not sufficient. Now it is getting added one more. Till you get the cumulative minimum 70%. Minimum 70%. Maximum it can be anything. But minimum 70 should be there. Yes, in the sequential order, it is going to add one by one. That is the importance now. Instead of adding the which is having low weightages, 3 or 4 of them or 5 of them, which is having high weightage, you can add only one. For example, one variable is having 50% weightage. As one of the student is asking one more question. We are having 50% weightage. One of them is having 10% weightage. One of them is having 2% weightage. One of them is having 3% weightage. One of them is having 15% weightage. 20 that one of them is having 20% weightage. Assume these are the total 6. Overall, the weightage is 1. Total weightage is 100%. Now, I want my requirement is 70%. My requirement is 70%. For getting the 70%, I can add 50 plus 10 plus instead of adding this, I'm going to add like this 50.5 plus 0.15 plus 0.02 plus 0.03. I'll get 70 also, right? 4 columns, if I add also, I'll get the 70%. If I add 0.5 plus 0.2 also, I'll get 70%. Now, which one I have to consider out of these two? Same 70%. Weightage is 70 only. But one is having with 4 variables, one is having with 2 variables only. Simple. So that you have to consider means first you have to make them in the descending order, and you have to add in the sequential order one by one. For example, my requirement is 50% only. My requirement is 50%. I can consider only a single variable or I can consider 5 variables cumulative. 2 options I'm having. Which one is best? In one variable only is sufficient means why 5 variables? But weightage is same only na. 50% only your requirement. If your requirement is 70 means that is not sufficient. But your requirement is 50 only. So till you get the weightage, how many variables are required, that many you are going to add. Is all the questions are clear in the PCA? Now the PCA is entirely the data was transformed. Point number 1. Point number 2, it is going to reduce the number of input variables. And this PCA has to be applied before to the modeling only, not after the modeling. It has to be taken before to the modeling. And after before to the modeling, whatever we are considering, by considering the before to the modeling, and we are trying to reduce the number of input features and we are trying to increase the accuracy. Now if someone unknown data of 13 input variables are there. Unknown data 13 are there. So let us take 13 values of your choice. Tell me of your choice, guys. Anything, just by observing this one, you tell me any numbers of your choice. Tell anything is okay. 15.5. Second one. Second column, tell me another value. Just don't give out of more values. Just observe this one and you give the values. 1.95, 2.5, 15.6, and 119, and 2.7, 3.06, 0.4, 2.25, 5.4. This is 1.01. And the next one is 3.6. Here I'm taking 3.6. And last one is 1000, round figure 1000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total 13 are there. Now, what are the 13 values are there? First, I'm considering this one as a list. That is 15.5. Out of the 15.5 is there. Followed by 1.5. Followed by 15.6. Followed by 119. Followed by 27. 15.6 comma 119 comma 27 comma 306 0.4. 1 minute. 2.25 5.4 1.01 3.6 thousand. Which is missing? 2.5 is missing. 2.5. Done. Okay. So total 13 columns. Let me check total length function. Let us apply the length function and let me check. So 13 are there. Yes. Now 13 values are there. Now for these 13 values, I have to predict. Now what I'm going to do, whatever the model is there, Second value is 1.95. Okay. Anything is okay. 3.06, huh? Oh, 306, 3.6 adi. After 27, after 27, whatever we have considered. Just a minute. Yes, it is 3.06, not 306. Okay, 3.06. Done. Everything is now perfect. Now, for example, whatever the model is there, this is the model. Okay, using your model dot predict. If you say the model dot predict like this, and if you say that, and if you give the input data like this, whatever the input data is there, this is the input data. And if you substitute the input data here, and if you ask means, it is going to throw the error. It will throw the error. Why it will throw the error? Because this model, whatever the model is there, this model was designed on how many input variables? 10 variables. Now, how many you have given? 13 you have given. Okay. So now what we have to do? Now what we have to do? First, this data, whatever this data is there, first this has to be transformed. Without transforming, you can't do that one. First, you have to do the transform. For transforming this one, what we have to do? For transforming, what we have to do? First, we have to convert this one to a data frame. And after converting to a data frame, then we have to apply the transform. So the same thing which I have explained during the lasso regression, ridge regression, and elastic net regression. Do you remember? First, we have to transform the original data, whatever the original data is there. First, you have to transform the original data. Then only you have to apply on the prediction. Without directly, if you give miss, it is going to throw the error. So first, what we have to do is, first we have to convert as a data frame like this. So whatever the input data was given to you, first you have to take the data frame. After converting the data frame, for example, here, let us take this one as the input data. This one I'm considering as my input data. First, this data, whatever the input data was given to you, this input data has to be transformed. So for transforming, what we have to do is pd dot data frame, and we have to create a df underscore test. Now you are having with respect to df underscore tester, where you are having with respect to 1 shape of the value passes is 13,1 and indices imply 1,1. Okay, I have not given this names. For each of them, I have to give the column names also. So otherwise, I can convert this one as a series. Series is possible. By converting to a series is possible, but I can't convert to a data frame. Data frame means I have to give the column names. Okay. So I can take like this. And when I have considered like this, I have to do the reshape. I have to do the reshape of -1,1. Then when I do the reshape of like this, reshape has no attribute called as a reshape. Otherwise, let us take this one as a series. Series dot a reshape function, a reshape of -1,1. Series also not having the because my shape of this one will be, if I open the shape of this one, xtrain underscore PCA. If I take this one, this is an array shape. So it is a 2-dimensional array. So I can convert as a two-dimensional array. Then let us take like this then. Let us convert this one to a two-dimensional array. How to convert it to an array? NP dot array of a input data. Whatever the input data is there. Input underscore data. Import numpy. Import numpy as NP. And you are converting. Done. It is converted. Now, whatever the data was converted, first what we have to do, this one has to be transformed. For transform, what we have to do, we have to apply the transform. What is the name we have created? PCA a model dot transform. So we are going to use that one. So by using the PCA transform, on which data we have to transform? DF underscore test. Okay. So this one will be transformed and I'm going to get the new data after transforming. So reshape of -1, 1. You have to give the values directly. You can't take like this. You have to give the column names. It is going to throw the errors. It is waste of time. Okay. Take that column names, each of the column names and work on that. Right now, next we are going to see the next part is the same thing. How it is going to work for the unknown data. Okay. That is model deployment part. Okay. Let's see the model deployment. Model deployment. So now you'll understand how it is going to work. So there is a business problem. There is a project, a small project I have considered. Okay. This is a very small one. So here I'm having the business problem understanding, that is predict the salary of a person based on the input variables. Okay. So the input variables, what is the input variables means you are having with respect to just a minute. Done. So the first one is business problem understanding. That is predict the salary of the person based on the input variables. Now, what is the data set means? I'm having a data set where I'm having the experience, test score, and interview score. These are the three things are available. Just give me a minute, guys. I'll close the kernel and restart the kernel. Done. So we have to predict the salary of a person based on the input variables, where I'm having the input variables are called as experience, test score, and interview score, and salary of a person. Now these are the things which we are having. Now here, if you observe, this data set consists of just of 8 records. I have taken a simple data set, 8 records, and here I want to predict based on this. Now, if I check in this data set, there are some missing values are available. And I'm going to replace the missing values, one by using with respect to the mean value and one by with respect to 0. The experience, in the experience column, if their missing values are there, means what is the meaning of that? They are not having the experience. They have not given the value, means they are not having the experience. So that is the value should be filled with the 0. You can't take the average score in that case. Okay, we can't take simply by df dot calculating of this particular column, what is the mean value, what is the median value. So replace with mean or median. We can't replace like this. So if the experience is not given, miss, we are going to consider the average that is 0 experience. They are not having any kind of experience. And the second column is test score. What is the next column which I'm having the missing value is called as test score. This is the second column. Test score means which was conducted in the company. The test was conducted within the company. Now within the company, the test was conducted and the test score was not available. So what we are going to do? We are going to collect the data who has conducted the test. For this particular person who conducted the test, we will check first. And from that person, we'll collect the data and we'll replace that value. Okay, in the real time in the companies, just we'll collect the data from the person and we'll replace. So in this case, the person is not available, nothing is available like that. So directly I'm going to replace with the mean. And once I have replaced with the mean, now my entire data was filled with the data. Now I'm going to do with the x is equal to drop the salary and y I'm considering the salary variable. And the train test split, I'm going to apply the train test split. And after train test split, I'm going to take the linear regression. Just I'm applying the linear regression because the output variable is salary. Salary is a continuous variable. So just I'm applying the linear regression. And after applying the linear regression, this is the quotient values which I have got. And this is the intercept value. Using the model, I'm going to predict on X test, predict on X train. And I'm going to calculate the train accuracy, test accuracy. Now I've got the train accuracy of 94%, test accuracy of 92%. Now this is the model and this is the best model. Assume this is the best model. Now using your model, what you're going to do means you're going to predict on a new person who is having a experience of 0, test score of 10 and entry score of 10. What would be the expected salary? If the experience is 0, test score is 10 and entry score is 10, what is the expected salary miss? So model dot predict on 0, 10, 10. And it is predicting the answer as 58,119. Sir, earlier the same thing we have tried in the PCA. At the time you have taken the double square bracket and you have given the input data. But at the time you told that it is not working and we have to give the column names you have told. But it is working now. Why? Because this is the original data consists of three input columns and I'm predicting also 3 input columns. For 3 input columns, there is no problem. When you want to transform the data, when you are transforming the data or you are reducing the data, then the column name should be clearly visible. If you are the same number of input columns are same, means no need of anything like that. So it is going to work in this case. Now, what is the answer I have got is 58,119. Okay. Now what I'm going to do, I'm going to save the model. How I'm going to save the model means from joblib, I'm going to import the dump and from the dumper, I'm going to save this model as the joblib file. I'm going to save this one as a joblib file like this. Already I have shown you how to save as a joblib file. Now, second way of saving is pickle file. One way is joblib file and one is pickle file. So in what way we have to save? Whether pickle file or joblib file is completely depends upon the requirements of the software developer. The software developer team is going to ask us, so please share the model as a pickle file, means we have to share them as a pickle file. If they send the requirements as save the model as a joblib file and send to us, means we have to share that one as a joblib file. Now, for example, if they ask us as a pickle file, then from pickle, you have to import the dump. Here you have imported from joblib. Here you have to import from the pickle. The same dump you have to take. So dump common. And what is the model you want to save? What is the model name you want to save? This is your model. What is your model name? Model name is model only. That is the model name, right? The model name, comma. Here you have to write the model name. What model name you want to save? The model name, comma. And in what way you want to save in your working directory. This is the syntax in the joblib file. Now in the pickle, what you have to write is which model you want to save. And second one is open model.pkl and wb. Means it is going to save as a model.pkl file in your working directory. So this will be saved in your working directory. This will be saved in your working directory. Is that clear, guys? How to save as a pickle file? One is joblib file, to save as a joblib file. For example, let us take for your easy understanding. I'm changing the model name called as LR_model. Okay, LR_model. This is the model. Okay. Now this is the model. And whatever the model LR_ is there, LR_model quotient, LR_intercept. And using your LR model, you are going to predict on xtrain. You are going to predict on the xtest using your LR models. And you are going to calculate using your LR model train accuracy. For your LR model, what is the test accuracy? Okay. Now here, if you want to save your model, what is your model name? Finally, which model name you are going to save? This is the model. What is the model name is called as LR_model. That is the model you want to save. So you have to write LR_model. How you want to save in your working directory? In what way you want to save? Some name you want to keep, right? The name, what is the name you want to keep? Miss, the name is called as HR_model. Some name you are going to create. Whatever the name. For example, you are writing like a project_model. Project model. Okay. .joblib means what happens? This LR model will be saved as the project model.joblib. It will be stored in the joblib file. How it is going to store means project_model in your working directory. Now what is, just open your working directory. So my working directory is this one, that is NIT. Within that model deployment. So can you see here? It was created a new file called as project_model.joblib file just now. In this way, you can create the joblib file, or you can create as a pickle file. For pickle file, what you have to use is from pickle, import the dump. And in the dump, you have to write what is the model name you want to save. The model name I want to save is LR model I want to save. How you want to save this one? You want to save this one as a pickle model. Name it as pickle model. Something I'm writing as a name. I'm giving the name as pickle_model. Here I have given the project_model. Here I'm going to give the pickle_model. So now I'm going to write like this. Now it is going to save in my working directory. So can you see here? Pickle_model.pkl was created just now. Is that clear? So like this, it is going to create in your working directory. Once it has created in your working directory, the models are created like this. Means now these two are there. Okay. Now what I'm going to do, just observe. So I'm having the head. I'm having, what are the two models I'm having is, what are the names I'm having? First one is pickle_model, project_model. Two models are there. I'm going to open the new file. Some new file. Now I'm going to open the new file, and I'm having with me, what are the models I'm having? Two models are there. One is pickle_model. One is project_model. Now, how I'm going to work here means, first from joblib, I'm going to import the load. I'm going to import the load function. Instead of importing the dump function, I'm going to import the load function. and I'm going to load. Which one I'm going to load? Joblib file. Which joblib file? What is the name I have created? Project underscore model. This is the name. So I'm going to use this one. Project underscore model dot joblib file dot joblib. So this file I'm going to load. Okay. Now this file was loaded. Now whatever the more it is loaded, how I'm going to save this one? Some name. You have to keep some name. What is the name I want to create? Tell one name, some name. Let us keep the name called as M1. M1 is equal to. Now this is having this one. Now using my M1 dot predict. Using my M1, I'm predicting for the unknown data like 0, 10, 10. If I predict the answer, I'm getting directly like this. So the entire linear regression I have not done. Nothing is there with me, but directly I have got the same answer. Earlier, whatever the answer you have got here, that is your model dot whatever the answer you have got, the same thing I have got. For example, here, if you change this one, check here for 9, 9, 0, 9 and 9. What is the answer? 54,379 is the answer. Now the same thing you'll get here also. 0, 9, 9. If you give, you'll get the same answer. Here, whatever the things you have done, this entire project you have done, and finally you are predicting. This entire project you are saving as a single file, and directly I'm going to use the single file only. Now, who can use this single file like this? Means who knows the Python? For example, I know the Python. I'm already a Python developer, or I know Python. So I can write from joblib import load, and after load, I'm going to write joblib file like this, and I'm going to predict like this. For unknown data, I'm going to predict. If I'm a software developer who knows the Python, for example, my HR is there in the company, HR is there. For the HR, I told that whenever you want to do the salary negotiation, first enter his experience. What are the experience is there? Enter here. Whether he is having 1 year of experience, what is his test score, and what is his interview score. After entering here, you'll get some value, and based on that, you do the negotiation. And based on the value, whatever the value you are going to get, you do the negotiation, right? Now, the HR is going to use this one when the HR will use this one means if the HR knows Python, because from joblib import load from a module, how to import a function, you should know that one. And they should know this program, how to write the program and how to execute in the Jupyter notebook, everything they should know. Either whether it is a Jupyter notebook, how many values I have to give. Yes, just a minute, Satish, I will tell you that. You'll understand. Just wait for another 5 minutes. You'll understand. Okay. So from joblib, you have to import the load, and in the load, you have to give the predict these values. Okay, fine. Now the HR, if the HR knows the Python means he can execute. Whether he can execute either in the Jupyter notebook or whether they're executing in the Spider or PyCharm, that is secondary, but they can execute. But the HR don't know the Python, but they want to utilize the model. How? HR don't know the model. At the same time, they have to utilize the model. How? In that case, means that is called as deployment. Means I'm going to create one deployment part. Means, for example, here I'm going to deploy this model. So for deployment, I'm going to use the Spider. I'm going to use the Spider. Why I'm using the Spider means the reason for software developers, we require the PY file. We don't require the IPNB file. We require the PY file. So PY file will be saved either in the Spider or PyCharm or Visual Code or something. PY file I require in terms of PY file. Right? Now here, what I'm going to do is just observe this. Okay, this is the PY file. Now this PY file, I'm just running. Okay, I'm just click on the run and it is getting running. Okay, what is the name I have created? pickle underscore model. Pickle underscore. I'm using the pickle file, either pickle or joblib. I'm using the pickle file for pickle underscore model. Pickle underscore model. Yes, now it is going to work. What? Pickil. Pickle. Done. See, now it is working. Now it is working, and I have got the some link also here. I'm copying this link. Whatever the link I have got here, just I'm copying and I'm pasting here. Now it is asking me to enter the values. I'm entering the values 0, 10, and 10. 3 values I'm entering, and I'm going to click on the predict. 58,119. Same answer. So if you write here 0, 10, 10. 0, 10, comma 10. What is the answer? 58,119. Same answer you are getting here. For example, here you are writing 1, tell me any values. For example, 2, 9, 10. Okay. Experience of 2 and a test score of 9 and entry score of 10. And 2, 9, 10. What is the answer, miss? 61,425. Let us see this one. 2, 9, and 10. And click on the predict. Same answer, 61,425. Now HR will use only this one. HR don't know Python. They will just enter the values like this and click on the predict. In the backend, the code is working. The model is working. Everything is working. Now, as one of the question, Satish from the online, he asked the question, sir, how I can know how many values has to be given? So HR will understand how many values. Experience code is clearly written. Test score is written. Entry score is written. So they will enter the values. In the backend, automatically pre-processing will be done. Transformation will be done. After that, modeling will be done. And finally, prediction will be done. Okay. So is that clear? So HR is going to use this one. HR don't know Python. They are not going to use the pickle file. They are not going to use the joblib file. This is called as deployment. So how this is going to work, that is the thing we have to understand. Okay, it is giving how it is working. What is the backend code I have written for this? So whatever the model, the entire model you are going to create now, finally you are going to identify which is the best model, right? That best model, you have to save it as a pickle file. That best model, you have to save it as a pickle file. Now, for example, I'm having the, let us take first a simple example. Let us start with a simple example. For simple example, this is the data set. Okay, this is the data set. For this data set, what are the data set I'm having? For this data set, I have created a model called as, this is the best model, final model. I have tried all the models and this is the finally the best model, assume. Okay, in this case, I have tried only one model, but assume I have done all the models and this is my final model. Whichever the final model, along with the hyperparameters will be there, right? Along with the hyperparameters. In the bracket, you'll have the hyperparameters, whether it is any other like KNN or SVM or decision tree or random forest, hyperparameters also will be there. That model, finally, whatever the model you have got as the best model, this model you are going to save as a pickle file. And you are going to share it to the team. To which team you are going to share, miss? To the software development team. Now, software development team is going to convert this one to a deployment. The deployment will be different phase. If deployment is required with website or deployment with respect to cloud or deployment with respect to another thing, that is entirely depends upon the software development team. That we are not going to do. For example, if they ask you to create a website, means we are not going to create the website, right? We are not the website designer. So they are going to do that one, right? So just our work is to share the model. Now, once we share the model, the deployment team is going to write the code like this. This is the code which they are going to write. Now, how this code is working means, so just observe this one clearly one by one. First, I'm going to import the NumPy as NP. From Flask, import the Flask request and render template. From Pickle, import the load. These are the things which you have to import. Now, what is meant by these three? So from import NP, NumPy as NP, I know. From Pickle, import the load. This also I know. These two I know. But what is this? Let us understand. One by one, I'll explain. Okay, let us see one by one. Now, first, I'm going to import the Flask. Now, what is meant by starting? Let us understand first what is meant by Flask. Flask is nothing but which is used for the deployment purpose, which is a micro framework. It is a micro framework. Now, what is meant by micro framework? Micro framework means which supports the website design for the small one, not with the huge one. If you are having with the macro, means high level, okay, big size of framework, if you want, means you are going to use some kind of Django frameworks. Now here I'm not going to use any kind of Django frameworks. Just I'm going to use the micro Flask. Flask means nothing but website design. So whatever you are seeing here, the website, this design is there, right? This is called as Flask. This entire design is called as Flask design. Okay. Now in this Flask design, what are I'm having? I'm going to do with respect to app is equal to Flask __ name. What is this one? Means you are going to initialize the Flask. You are doing the initialization of the Flask. You are going to do the initialization. Okay. You are starting the Flask in order to run the Flask. How you are going to run the Flask means this Flask you are going to store in the app, some variable called as app. When the app runs, automatically your Flask module will run. Now, first what I'm going to do is I'm going to load using here from pickle.load is there, right? Using the load, I'm going to open the pickle file. Whatever the pickle I have saved earlier, using the dump file I have saved that one, that I'm going to load here. Earlier, I have used the dump function. Using the dump, I have saved that one. This time, I'm reading that one. I'm opening that one. So here, I'm going to take the pickle file RB. RB means read format. Earlier, if you observe here, in this, earlier I have written the, whatever the pickle file is there, this pickle file, I have written here WB. What is meant by WB means write file. Write mode. It is going to write. Write means it is going to save that one. RB means read mode. RB meaning is read mode, means which is going to open that one. One is going to save, one is going to open. So dump file will save the model, load file will open the model. Okay. So now here, whatever the model is there, in this, just I'm opening the model. So this is the file which I have saved. And this file should be in your working directory. Wherever the spider file is there, this one also should be in the same folder. Otherwise, you have to change the working directory. Already I have told you this one. So now you are having with respect to the pickle file in the RB mode. RB mode means reading mode. You are going to read. Now, once this file, whatever the pickle file is there, this pickle file, you are going to save as a model name called as loaded_model, some name. Whenever you are going to open that one, you have to create into a new model. So similarly, I have shown you how to create in the dump, this one. So once you have loaded, you have to save into a some name. Choice is yours, some name, but you have to create one name. So the name is loaded model. Okay. Now what happens in the loaded model? What it is going to load the model? Which model it is going to load? It is going to load the pickle model. In the pickle model, what is there? Linear regression is there. So finally, it is going to load the linear regression. Simply, it is going to load the linear regression. Is that clear? Finally, first you have saved the linear regression, and that same linear regression you are going to use now. Sir, instead of saving and loading, directly you can save the linear regression only now. See, directly if you import the linear regression, And if you save the linear regression directly here itself, data will not be given, right? This linear model, whatever the linear regression model is there, including the data is there, including the X train, Y train is there. So it already fitted. Whatever the model you are saving here, for example, I'm saving like this. So in this model deployment, here you are going to save the model. When you are saving the model, you are not only saving this one, you are also saving with the fit, because already it has fitted. Now it is not storing the empty one. It is storing the coefficient values. These values are getting stored. Now in the backend, it is storing this beta naught plus beta 1 xn2 plus beta 2 x2 plus beta 3 x beta 2 x2 plus beta 3 x3. It is storing these 4 values. It is storing. It is not storing the empty one. It is not storing the empty one. Without fit, let us remove this line. By removing this line, if you ask what is the quotient, what is the answer you are going to get? If you remove this line, and just you have imported linear regression, and the linear model is equal to linear regression, and you have not fitted. Without fitting, how you can calculate the beta naught and beta 1? Fit means calculate. Without using the word fit, from where it will calculate? So without calculation, how the values will be saved? So now whatever you are saving here, in this whatever you are saving, it is saving the beta values. Beta naught value, beta 1, beta 2, beta 3, it is saving. It is saving that one. And along with the, so in the backend, what it is going to do is, it is going to save like this. That is beta naught. What is the beta naught value? 20,722.33184 plus beta 1, that is 2716.4868 into experience plus 2126.9203 into test score plus 1612.7795 into interview score. This entire thing is getting stored in the backend. This formula is getting stored. I'm saving this one. And the same thing I'm utilizing here. I'm opening the same thing here. Now the same formula, whatever is there, this formula is nothing but I'm going to store in the loaded underscore model. Now it is clear. Now loaded model means this is the model, it is loaded. Now whatever the values you are going to give, it is substituting the experience value, test score value, interview score value like this. Now if experience is equal to 0, test score is 0 and interview score is 0, what is the answer I'm going to get? What is the answer? Only this quotient value, right? If these 3 of them are 0, what is the answer? 0 into this one is 0, 0 into this is 0, 0 into this is 0. What is the answer? 20,722, right? This is the answer. Let us see. Let us see whether we are getting the same or not. Whatever I'm having here, first I'm going to give 0, 0, 0, and I'm getting predict. What is the answer I have got? Is that clear? For example, interview score is 1. Interview score, sorry, not interview score, experience is 1, 0, 0. Now what is the answer? 20,722 plus 2,000. Let us open the calculator. Let us open the calculator. That is 20,722 plus 722 plus 2,716. 23,438. After that, decimal values. What are the decimal values? 23,438 I have to get. If I write here 1 and this is 0 and this is 0, then automatically this is 1, 0, 0. 0 into this one is 0, 0 into this one is 0, 1 into this one is 2,716, 20,722, which is nothing but 23,000. 438. 23,438. So 23,438. That is the answer which you have to get. Is that clear? Just it is saving the equation. Just it is saving the equation. And the equation, whatever the values I'm entering, it is just keeping that values and it is giving the answer. Just it is saving the equation. Now, whatever the equation it is going to save, see here, it is saving the equation. This is the equation it has saved. Okay. Now here at the rate of app.root hash, okay, backslash def home render template called as index.html. Means I have created one HTML file. So it is going to render the template. It is going to render the template called as index.html. This file it is rendering. Rendering means run. Render the template means run the HTML file. The meaning of render template means render underscore template. Render underscore template means render means run. Run the template. Run the template. Whatever the template is there, run the template. What is the template means? Whatever the HTML file. Who is going to create this HTML file? Software developers will create. If you know already HTML means you will create. If you don't know HTML means generally HTML creation or CSS. Sir, HTML, should we learn the HTML? Okay, learn the HTML. If tomorrow, if you have to use, you have to deploy the model in Django means you'll learn Django also. Na? If they ask you to deploy in the SAP means SAP also you'll learn. Na? How many you learn like this? Your work is data scientist and to predict the model with maximum accuracy. That is your work. Other work others will do. Right? That is not your work. So creating the HTML is with respect to others' work, software developers' work. Who is the front-end and front-end developers are there? They are going to create that one. So they are going to create this HTML file. And I'm going to run the HTML file. Render the template means I'm going to run the HTML file. Opening, first, you have to start to render the HTML file. How it is going to open the HTML file means app at the rate of app. App means what? Flask. In the Flask, first, opening itself, opening means this one. So whatever this one is there, 122 dot, this one I'm entering now. Here, if I enter these values, can you see here? Automatically you'll get with respect to slash, one slash automatically you'll get. When there is a slash, automatically first you run the template. Which template? HTML template. The hash meaning is that. Here, whatever the hash is there, that it is going to run. So in the other websites, some for example, if you open the Naresh IT, I'm opening the Naresh IT website only. In the Naresh IT website, I'm going to click on the all courses. If you see here, hash, automatically hash has came. I have entered only Naresh IT. I have not entered the slash. If you observe this one, I have entered only nareshit.in. But when I have clicked on this and all courses, automatically I have got here one backslash. Now, what is meant by backslash means automatically it will run the first opening. What is there in the backend code? It is going to run. In the backend, for this particular website, they have written the another template. And they have created, maybe it has created, this is not created using the Flask. It was created with respect to some advance. Okay. Now, just when first opening itself, you have to open the home. Home is open the render template, this one. That is the first step you have to do. The hash meaning is that one. Is that clear? Now, after the hash, now whenever there is a predict, someone click on the predict button, then what you have to do? Someone click on the predict. So after clicking on the predict, it is going to work only after clicking on the predict. Otherwise, it will not work. Once you click on the predict button, there is an option called as predict. Sir, how I can know that predict option is there? Miss, in the HTML file we have created now. Which button is there that we have created? So there is a predict option. Once the person has executed the predict, now what it has to do is it has to take the whatever the request.form.values means. First, let us keep this code side by side and I will explain. In this side, I'll take. Okay. So here, what first, once you click on the predict, First, what it is going to do means for X in the request form. For X in the request dot form dot values means whatever the values I have entered 199 I have entered like this. For X in request dot form means it is requesting the values to be entered. It is asking the user to enter the values. Request means asking the user to enter the values. Whatever the values they have entered, it is going to store in terms of int of X means it is going to create a list of 199. It is going to create like this. The moment 199 I entered, it is going to create first list of 199. This 199 is converted as an np.array. So np.array, it is converting this one to an array. Okay, np.array. Now np.array it is converted. After converting the np.array, now it is I'm asking the model dot predict on this one. Now model is there and model dot predict. So now it is going to predict and I'm going to get the output. Okay, when I use the model.predict, automatically get the answers, right? So it is just giving the answers. Is that clear? Is that clear? Got the point? So first, whatever the values are there, these values, it is taking as a list of 199. And these list of values are getting converted to an array, that is two-dimensional array. And that two-dimensional array, directly I'm going to use the model.predict. For example, you have dropped some of the columns. In between only you have to write the data pre-processing. What are the data pre-processing is there? Between this one to input data, you have to write the data pre-processing. Enter data pre-processing, you have to keep in between this one. For example, you want to drop one of the column. So first you are converting this one as an array. After converting an array, convert to a data frame. In the data frame, drop that particular variables. Which are the variables you want to drop? Remove that. And after removing, finally, whatever the remaining variables are there, that remaining variables will be used for the prediction. And once it is predicted, now, so it is going to return the render template. Render template means in the template, in the index.html, there is a prediction.txt. So I'm opening the template. Okay, here you can see the template I have created. This is the template. So in the template, I'm having input values. The user has to enter the 3 input values. And the moment they click on the predict button, here in the prediction underscore text, something was given here. Can you see? This value should be filled with. This value should be filled with employee salary should be in terms of dollars off. It should be filled like this. So that is the reason you're going to get here employee salary should be dollars off like this. Why you are getting that one employee salary should be like this means because I have written that one. For example, you have not this whatever the things are there. For example, you have not written this. You have not taken like this. Just simply dollars. Just you have given the dollars. Okay, dollars of dot format. You are going to use the dot. I'm writing the dot format. I can write or either print or anything, right? So I'm using the dot format and simply dollars. Now it is going to print what it is going to print here. In this case, what it is going to print? Just only directly the dollars. It is going to print just dollars. It will not print anything. This part will not be printed. Only dollars will be printed. Is that clear? If you want, you can check. Just give me a minute, guys. I'm closing off everything. Okay. All of them I'm closing off. And this one also I'm closing. Okay. Or I'm going to do with respect to restart the kernel. I'm going to stop the kernel and I'm going to re-execute the kernel. So for re-executing the kernel, first we have to stop the kernel. So I'm going to click on the stop button. So that is the reason why the software engineers will use the with respect to Spider or PyCharm or something like this, because they require the PY files. They don't require the IPNB files. Right? Now here, just observe this one, pickle underscore model, and I'm taking only dollars. This time only dollars. So now what happens? Whatever the values I have entered. So just observe this. Okay. First, when I run this one, when the file I'm running, first, it will go to which position? Okay. First, it will go to the, it will start running the first file. What is the file is there? That is Flask file. First, it will run this one. Okay. First, it is going to run this one. After running this one, now it is going to load the model. Whatever the model is there, that is model is nothing but whatever the saved values. And it is going to run the HTML file. And whatever the values I have entered, it is going to convert everything to an array. And after converting to an array, the model is going to predict whatever the loaded model is there, loaded model dot predict on the data. And it is going to run the template. And this prediction test, the prediction test will be filled with only dollars and the square curly braces. And these curly braces should be filled with whatever the answer of this one is there. That is prediction value. Means whatever the predicted value is there, model dot predict is there. This value should be printed in this way. Is that clear? Now the same thing. Now I'm just running this code. Once again, I'm running this code. Okay. Now whatever the here I have got, I'm just copying this one. Every time it is going to be fixed and it is going to work in the local server. It is not the web server. It is the local server. Local server means it is going to work in only in your machine. And here I'm writing with respect to 0, 9, 9. Something I have written like this. Now I have got only dollars. Why I have got only dollars? Because in the text I have given only dollars and directly the value. So that is the reason it is giving that value. Right? It is running the template. Whatever the template is there, the template is getting run. In the template, I want to fill that prediction text. Whatever the prediction text part is there, that value should be filled with this one. So now if you open your template, now you can see this, both of them side by side. So whenever you have entered the values, so this value is 0. You have entered here 0, here 9, here 9, and you have clicked on the prediction. And automatically this prediction text here, whatever the prediction text is there, this prediction text has to be filled with $, and the value, whatever the value is, the value is nothing but equal to your prediction. Whatever the value is there, that it has to fill. It is filling with that value. The prediction text will be filled with that value. Is that clear now? Now in this way, the deployment part works, and the HRs are going to open this one, and rest they are going to fill the values only. They don't know nothing Python. They don't. How it is working also they don't know. Just they know only one thing is they know how to enter the values. For example, in the HDFC Bank, one executive will be there who is going to collect the documents, personal loan documents or educational loan documents, or with respect to agricultural loan documents. What are the documents? After collecting the documents, they are going to enter in the system. They know how this software works. Nothing they know, just their data entry operators. Their work is to fill the values and click on the save button. Their work is related to finance. What is the percentage we have to give? How much this person is capable of paying the loan or not? That they will see. But they don't know how these values are getting stored and how in the backend it is saving in the SQL database, how it is going to store the values, every value in the backend, how this website was designed. If this button is not working, what we have to do? He don't know anything. For example, if he's going to click on something, if it is not working, means what he'll say? Immediately he'll call to the customer care or to the whatever the maintenance department is there. To them, he is going to call and he's going to say that I'm getting some error, please check. He don't know anything now. His work is to entry only. Similarly, in the company, HR work is to enter the values and click on the predict button. They don't know Python. They can't open the Python. Whatever the saved file you are giving or with respect to Jupyter Notebook, if you give, they'll not understand anything. Client also doesn't understand anything. For example, if you want user car prediction, cars24.com is there. In that cars24.com, you have to create a website like this and you have to give the values and the user is going to enter the values and click on that. If you give the Jupyter Notebook and if you give that take this one, apply this one, this is important parameter. If it is not there, you collect this one. If you say like this means he will run away simply. The executive don't know anything. The customer don't know anything. They know only one thing is called as one tool will be there in one software will be there. For example, the same software you want to asset, for example, the same thing, whatever you are seeing as of now, the same thing as it is, you want as an Android app. Means in your Android mobile, if you open, the same thing should be visible. And once you enter the values and if you click on the predict means, it has to show the value. For Android app, are you going to learn the Android? No, that is the work of a software developer. Android developers work that is. Our work is to predict the model with maximum accuracy. Instead of 92%, how we can get 100% accuracy, that we have to focus. Instead of getting the train accuracy, test accuracy 92, how we can get 100% or 98% maximum accuracy. We have to think in that way. Our work is for prediction, not for creating the website. Okay, is that clear, guys? Now, Sri Charan is asking, sir, we need two different HTML files for different project because we need a different input variables, obviously, right? For each project, different HTML file is required. According to that, what are the input variables are there, we have to take. In this HTML, I have created with 3 variables. If 20 variables are there, means with 20 values, you have to create the HTML file. If 2 values are there, means 2. Okay, is that clear, guys? Done. So that is with respect to called as model deployment, right? Next, we are going to next one would be on the next Monday. There is no class. Monday there is no class. I'm having some personal work and I'm on leave on that day. Okay, I'm having some personal work. So I'm on leave on the Monday. The next class will be on the Tuesday. So you are having a good enough time for practice of the classification and everything. You can complete all the classification algorithms along with the regression. The entire supervised machine learning was completed. Now on the Monday, Tuesday, we are going to start the unsupervised machine learning. Either we can start unsupervised machine learning or NLP also. In the NLP also, for example, NLP is there. That is your emails. What are the emails are there? That emails are getting classified, whether it is a spam mail or whether it is a normal mail. That is also a classification project. But text data. Data is text data. Instead of a structured data, tabular data, you are having a text data. The text data has to be converted to a structured data. Then you have to apply the ML algorithm. Only the data pre-processing changes. In the entire text data, only the data pre-processing is changing. Nothing else will be changed. How your Google Assistant will work, you know, just open your mobile phones. Okay, Google. And now how you are working, tell me. If you ask like this, it will take the process now. Now what you are speaking now, it is going to take that one, the sentence. And the sentence will be converted in the backend as a structured data. And the structured data will be passed into that machine and it will give the output. Because the machine will understand only the structured data, directly will not understand the unstructured data. Any data has to be converted to structured. Even images also has to be converted to structured. Even videos also has to be converted to structured. Everything has to be converted to structure only, then only then the machine will work. Machine knows only the structured data, the machine knows only with the numbers. Directly the text, the machine doesn't understand the text data directly. It has to be converted to structured data and encoded. The process is a different process. That's it. Is that clear? So that we are going to see, and we'll discuss the next one on the Tuesday, right? Monday is a holiday and you are having Saturday, Sunday, Monday, 3 days for practice. Okay, use this one for practice instead of going to hometown. Don't call your parents, sir, it's on holiday on Monday. So 3 days holidays I have got. So I'm coming to the hometown. Don't say like this. Okay, who are staying in the hostel, don't go to your hometown. Stay in Hyderabad only and stay in the hostel only and practice only. Okay. Yes, coming to the test. If you're ready, miss, tomorrow itself I can conduct the test. If you're not ready, miss, practice for these 3 days and on Tuesday we can conduct the test. Tuesday or Wednesday, something. If you take that time, miss, obviously my requirement also will be very high, miss, in terms of you have to get a very good score. Okay, you're asking the time and I'm giving the time for practice. Everything we are taking in a positive way. At the same time, result also should be positive, right? So tomorrow there is no weekend test. So practice these 3 days and apply all the algorithms by considering any one data set, like diabetic data set is there. For that only apply the logistic regression, KNN, apply SPM, apply decision tree, apply random forest, apply ADA boost, gradient boost, exit boost, everything. And with PCA, without PCA. Try all of them, whatever the things you can do. And I want the diabetic data set with maximum accuracy. That is my requirement. What you want, you do. Create a predictive model which can predict whether the person is having a diabetic or not. Yes or no. I want with maximum accuracy. That is my business problem. This project you are going to complete. What you want, you do. Is that clear? Already you are having the diabetic data set with you. Done? Right, guys. That is the end of the session and we'll continue on the Tuesday's class.